இந்த வீடியோட தமிழ் வெர்ஷன் கமெண்ட்ல பின் பண்ணிருக்கேன். Make use of it. Welcome to the video on data communication. First, we will understand what is data communication. In that, we will study characteristics of good communication. After that, components of data communication. Moving further, types of data, that is message formats. And finally, data flow directions. Without any further ado, let's get started. What is communication? Communication means sharing information. This sharing can be local or remote. There are two types of communication: local communication and remote communication. Local communication, this type of communication occurs face to face, which allows for direct interaction between individuals, like talking to a friend. Remote communication, this type of communication happens over a distance. It needs network or device to connect. Example, phone call or video chat. Now, what is telecommunication? It means communication over a distance. The word tele comes from Greek meaning for. Telecommunication is a big concept. It has three main types: telephony, talking over the phone, which is voice communication; telegraphy, sending text messages using code, like Morse code; television, sending sound and pictures to faraway places. Now, what is data? Data is just a fancy word for information. It can be a text, voice, video, image, etc. The data should be in the same format, so both sender and receiver can understand it. What is data communication? Data communication means exchanging data between two electronic devices like computers or phones using a medium like cables or wireless signals. But for this to work properly, we need hardware and software. The hardwares are physical parts like cables, routers, computers, and modems. The softwares are the programs that control how data is sent and received. So data communication works only when both hardware and software work together. Now, for a communication system to be effective, it should have four key features, which are delivery, accuracy, timeliness, and jitter. Delivery means the system must deliver data to the correct destination. Data must reach the intended device or user. That is, only the intended recipient should receive the data. Therefore, it ensures privacy and security. Next, accuracy. It means the system must deliver the data accurately. The data must reach without any errors. If data is altered while sending, it becomes incorrect and cannot be used. After that, timeliness. It means the system must deliver data in a timely manner. Data delivered late are useless. Think of a Zoom call or live stream. If there is a delay or lag, it becomes hard to talk or watch. That's why real-time delivery is important. It feels like it's happening live. In audio video, data must be sent as it's created, and it should be in right order with no delay. This is called real-time transmission. Next, jitter. This is a slightly tricky one. Jitter is variations in packet arrival times. It can lead to uneven quality in audio or video streams. Imagine a video is sent in small parts called packets. These packets are sent every 30 milliseconds. Like first packet after 30 milliseconds, second packet after 30 milliseconds, and so on. Some packets reach in 30 milliseconds as expected, but some packets reach late like 40 milliseconds. Now what happens is, the video will not play smoothly. It may look lag, pause, or look choppy. This kind of uneven delay is called jitter. So jitter is variation in packet arrival time, and it affects video and audio quality. A data communication system has 5 components. To understand how data is sent and received, we need to know these 5 important parts. The 5 components of data communication system is message, sender, receiver, transmission medium, and protocol. Message. The message is the actual data or information we want to send. It can be a text like message, numbers, pictures, audio, and video. For example, hello sent through WhatsApp is a message. So message means what is being sent. Sender. The sender is the device that starts the communication by sending the message. It can be a computer, mobile phone, camera, and telephone. For example, if you send a voice note to your friend, your phone is the sender. So sender is who sends the data. Receiver. It is the device that gets the message from the sender. It can be a computer, mobile phone, TV, and telephone. For example, your friend's phone receiving your voice note is the receiver. So receiver means who gets the data. Next, transmission medium. It is the physical path by which a message travels from sender to receiver. Some examples of transmission media includes twisted pair wire like telephone wires, coaxial cable like TV cables, fiber optic cables like Geofiber, Airtel fiber, BSNL fiber used for high-speed internet, and radio waves used in Wi-Fi and Bluetooth. For example, if you send a file over Wi-Fi, the radio waves are the medium. So transmission medium means how the message travels. Next, protocol. A protocol is a set of rules that governs data communication. So it is like a language or agreed set of rules that both devices follow to understand each other. Without protocol, even connected devices can't communicate correctly. Example, imagine one person speaks Tamil and other speaks Japanese. Here they don't understand each other. But if both speak English, communication works. Here English is a common protocol. So protocol means rules of communication. Now let's understand what is message in data communication. A message is an information that we want to send from one device to another. Information can be in different forms like text, number, image, audio, and video. In data communication, text is represented as bit patterns, that is series of zeros and ones. This is called bit pattern or binary code. Now what is code? A code is a set of predefined bit patterns used to represent each symbol or character. So process of converting text to bits is called coding. The most commonly used coding system is Unicode. Unicode can represent characters from any language. It uses 32 bits for each symbol, that is 32 ones and zeros. For example, a letter A in Unicode might look like this. Next, numbers. Numbers are also represented by bit patterns. Here, code such as Unicode is not used to represent numbers. Instead, a number is directly converted to a binary number to simplify mathematical operations. After that, images. Images are also represented by bit patterns. An image is composed of matrix of pixels, where each pixel is a small dot. The number of pixels determines the resolution of an image. For example, an image can have 1000 pixels or 10,000 pixels. More pixels leads to better quality but require more memory. After dividing an image into pixels, each pixel is assigned a bit pattern. For images made up of only black and white dots, one bit pattern is sufficient. If an image is not made up of pure white and pure black pixels, you can increase the bit size to include the grayscale. That is, you can use 2 bit patterns to represent 4 levels of gray. A black pixel can be represented by 0, 0, a dark gray pixel by 0, 1, a light gray pixel by 1, 0, and white pixel by 1, 1. There are several methods to represent color images. One method is called RGB. This method combines 3 primary colors, red, green, and blue. The intensity of each color is measured and the bit pattern is assigned to it. Another method is called YCM. This method uses the combination of 3 primary colors, which are yellow, cyan, and magenta. Next, audio. Audio means sound, like voice, music, or any noise. For example, talking on the phone, listening to music, voice notes, etc. So it refers to recording or broadcasting of sound or music. By nature, it is different from text, numbers, or images. It is continuous, not discrete. Even when we use a microphone to change voice or music to an electric signal, we create a continuous signal. Next, video. It means recording or sharing of moving pictures, like a movie or live stream. It can be produced in 2 ways, which are continuous and discrete. Continuous means like live camera. For example, a TV camera captures video as a continuous flow of motion, whereas in discrete, it is made frame by frame. Here, video is made from many pictures called frames, and it is shown very fast, and we see it as a smooth movement. For example, in cartoon movies, each picture is drawn separately, but when shown fast, it looks like the characters are moving. Now let's understand data flow in communication systems. When 2 devices communicate, the flow of data between them can happen in 3 ways, which are simplex mode, half-duplex mode, and full-duplex mode. In simplex mode, the communication is unidirectional, like one-way street. Only one of the 2 devices on a link can transmit, other can only receive. Keyboards and traditional monitors are examples of simplex devices. The keyboard can only introduce input, the monitor can only accept output. So in simplex mode, data can go only in one way and it uses the whole channel for that. In half-duplex mode, each station can transmit and receive but not at the same time. When one device is sending, the other can only receive and vice versa. It is like one lane road. Vehicles can go both ways but only one side at a time. Example, walkie-talkie and CB radios are half-duplex systems. This mode is useful when simultaneous communication is not necessary. The channel's full capacity is used by the device which is sending the data at that moment. Next, full-duplex mode. It is also called as duplex mode. Here, both stations can transmit and receive simultaneously. It is like a two-way street with traffic flowing in both directions at the same time. When two devices are talking at the same time, they need to share the communication path. This is done in two ways, either by having two separate paths, that is, the link must contain two physically separate transmission paths, one for sending and one for receiving, or we will logically divide the channel's capacity between the signals going on each way. One of the examples of full duplex communication is telephone network. When two people are communicating by telephone line, both can talk and listen at the same time. Full duplex mode is useful when we need a constant two-way communication, and the capacity of the channel must be divided between two directions.